Namaste everyone and welcome back to our channel. Today, we are diving deep into one of Java's most powerful and elegant features, the Java Streams application programming interface. If you've ever found yourself writing lengthy loops to process collections, then this tutorial is for you. The Streams application programming interface, introduced in Java 8, offers a declarative and functional way to process sequences of elements. It helps you write cleaner, more readable, and often more efficient code. In this 5-minute whiteboard tutorial, we will explore what streams are, how to create them, perform intermediate operations like filtering and mapping, and finally, how to collect your results using terminal operations. Get ready to transform your Java coding style. Alright, let's begin with the fundamentals, creating streams and performing intermediate operations. Think of a stream like an assembly line in a factory. You start with a source, like a list of items. To get a stream, you simply call the .stream method on your collection. Once you have a stream, you can apply intermediate operations. These operations transform the stream but do not produce a final result. They are lazy. For example, filter allows you to select elements that match a certain condition, like picking only the red apples. Then map transforms each element, perhaps changing an apple into apple juice. These operations can be chained together, forming a pipeline, but the stream remains open for further processing. Now that we've transformed our data using intermediate operations, it's time to get a result. This is where terminal operations come in. Unlike intermediate operations, a terminal operation consumes the stream and produces a final result or a side effect. Once a stream has been consumed by a terminal operation, it cannot be reused. It's like the end of our assembly line, where the final product is packaged. A common terminal operation is for each, which simply iterates over each element and performs an action, for example, printing each item. Another very powerful one is collect, which gathers the elements into a new collection, like a list or a set, or even aggregates them into a single value. This is incredibly useful for transforming your stream back into a usable data structure. Let's put everything we've learned into a practical example. Imagine we have a list of person objects, each with a name and an age. Our goal is to find the names of all people who are 18 years or older, and then collect these names into a new list. First, we create a stream from our list of person objects. Next, we apply a filter operation to keep only those persons whose age is 18 or greater. After filtering, we use map to transform each person object into just their name, which is a string. Finally, we use the collect terminal operation with collectors.toList to gather all these names into a new list of strings. See how elegantly we can achieve this complex task with just a few lines of stream code. This is the power of the Streams application programming interface. While Java streams are powerful, there are a few common mistakes beginners often make. Firstly, remember that streams are designed for single use. Once a terminal operation has been applied, the stream is considered consumed and cannot be reused. Trying to use it again will result in an illegal state exception. Secondly, Avoid modifying the source collection while a stream is being processed from it. This can lead to unpredictable behavior. Thirdly, be mindful of performance with very large datasets. While streams are often efficient, complex pipelines can sometimes be optimized further. A good practice is to keep your stream operations stateless and non-interfering. Always aim for immutability within your stream pipeline, ensuring that each operation produces a new result without altering the original data. This leads to more predictable and robust code. And just like that, we've reached the end of our 5-minute journey into the Java Streams application programming interface. Let's quickly recap what we've learned. We saw that streams provide a declarative and functional way to process collections. We explored how to create streams, apply intermediate operations like filter and map to transform data, and then use terminal operations such as for each and collect to produce a final result. Remember, streams are lazy, single-use, and promote a clean, readable coding style. Keep practicing these concepts with your own data. The more you use streams, the more intuitive they will become. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and don't forget to subscribe to our channel for more exciting Java content. Happy coding!